everyone, welcome back to the Minnal KEAM series 2023 for your KEAM preparation. I'm Sana Khan, your maths master teacher, and today I have brought for you Differential Calculus Part 2, where we will be discussing application of derivatives and limits and derivatives chapter. Well, limits is from your class 11th, AOD is from your class 12th, but both of them are super important because if you observe the question paper, then these two chapters combined are 13 to 14 questions. Yes. So basically, they constitute a major portion of your syllabus. So definitely they are super important. And do you know what? They are not that difficult. So let's learn about them one by one in detail, solving PYQs, looking at each and every formula and summarizing it for you as well. Alright. So if you are new on this channel, don't forget to subscribe Vedantu Malayalam because here you will get complete Kerala entrance exam preparation. In this 1 week itself, we are helping you revise all the chapters, all the formulas, all the PYQs in the marathon series going on. So do subscribe if you also want to get the maximum benefit out of it. Alright, so yeah. Also, do share the video with your friends too. They should also get some benefits, right? We should not be selfish and restricted to ourselves. So do share the video and hit the like button if you enjoyed today's class. So, are we ready to start? Let me know in the comment section quickly, and we will now learn about limits. Now, limits are basically having lots and lots of formulas, lots and lots of different methods to find out the limit. But do you know what? In your KEAM exam, there is a particular pattern being followed, and there is shortcut trick to find out limit of every question, and that we will learn today. Okay. So first of all, what is limit? Limit is basically value of a function which approaches as the input approaches some value. So basically, limit is a value which you get by approaching a single value. For example, you say that at x is equal to c. I want to define my function. Now, at this point, what we see is that for a value just greater than c and just smaller than c, are we still getting same values? Why do we check that? We use limits to check continuity of a function. So basically, we call it as a left hand limit and a right hand limit to determine whether our graph is continuous or not. Okay. Now, moving on. What are the different methods to find out limits? First is direct substitution, factorization, rationalization, sandwich theorem, and L'Hospital's rule. Now, there are some formulas related to it. What are they? First is, so whenever your function is of the form 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, 1 to the power infinity, or infinity to the power 0. In all this situation, the limits are called as intermediate forms, and we have some methods to basically eliminate this form and to find out the limit. Okay, so we'll learn about them one by one, but before that, let's remember the formulas and the properties of limit. Property number 1, limit x tends to a, c of function. So basically, a constant multiplied with function is basically limit of the function multiplied with a constant, because for a constant, there is no limit. Only we can apply limits to functions, right? Now, similarly, limit applied to a function to the power m is same as limit applied to the function and then raised to the power m. Limit of fx plus minus gx is limit of fx plus minus limit of gx. Limit of e to the power fx is e to the power limit of fx, because limit is only applied to the function, so not applied to e, so it's one and the same thing, right? Now, some important results that we use a lot. Number 1, e to the power mx minus 1 upon x. So whenever you see a function in this format, what do you see? You see that e to the power 0 will be e to the power 0 minus 1 upon 0 is what? This is nothing but 1 minus 1 upon 0. So 0 by 0 format. Now this 0 by 0 format can be eliminated by doing differentiation using L'Hospital rules. And from there we have derived the formula. If your function is of the form e to the power mx minus 1 upon x, it can be written as m directly. Similarly, if your limit is of the form limit x tends to a, x to the power m minus a to the power m upon x to the power n minus a to the power n, then it can directly be written as m upon n a to the power m minus n. Limit x tends to 0, a to the power x minus 1 upon x is log base e of a. Okay, so directly you can use this formulas. Of course, it's not a subjective question, it's an objective question paper. So you have to use the direct formulas and remember it. No need to do differentiation, then find out the answer and all of that. Okay, next, log base a 1 plus x upon x is log base a e. Okay, when the limit is approaching to 0. Next, sine mx upon x is basically equal to x upon mx equal to sine inverse mx upon x equals to m. So always you can directly write your answer as m. Why that happens? Because if your limit is approaching to 0 and your function is of the form sine x upon x, the answer is 1. What is 1? 1 here is basically the coefficient of your variable. So if it is mx, the answer is m. If it is x, the answer is 1. Direct formula. Similarly, tan mx upon x is m. Sin x upon x, cos x upon x is 0 when the limit is infinity. When the limit is 0, it will be 1. When the limit is infinity, it will be 0. Remember, don't get confused. Next, limit approaching to 0, 1 minus cos of mx upon 1 minus cos of nx is m square upon n square. These are all the direct formulas that you have to memorize. Okay, I'm not going to explain those formulas because no need of that. And right now we are not focusing on the basic concepts. We are just focusing on direct formulas which are helpful for your problem solving. Next, cos mx minus cos nx upon x square is n square minus m square upon 2. Remember, m minus n, but here n minus m. Okay, please remember these small basics I'm telling over here. Now, yeah, I guess, okay. So these are basically the results we use, the formulas we use to find out limit of a function. Now, there are some basic concepts used to find out limit, but that I will explain with the help of questions. Okay, so what we are going to do, we are going to solve many different type of questions, and with the help of that, I'm going to explain you how you approach any question and how you solve it. Okay, let's begin. Question number 1. If your function is 2x for x less than 1, fa minus x for x greater than 1, is it continuous on real number? If it is continuous on real numbers, then the value of a is dash. Now for these type of questions, for checking the continuity, any function is continuous when the left hand limit is equal to the right hand limit. Now here, since your function is already defined for greater than 1 and less than 1, so what we will do, we will left hand limit will be function at x less than 1 and right hand limit will be the function at x greater than 1. So for less than 1 your function is 2x. For greater than 1 your function is 5a minus x, where x is equal to 1. So 2 into 1 is equal to 5a minus 2. So, sorry, 5a minus 1. So this will go here, 2 plus 1 is 5a. So this implies that a is 3 by 5. So that should be your simple answer, that a is 3 by 5. Okay. Now, so like this we use limits to check continuity of a function or to find out the unknown variable. Next type of question. Suppose they have given limit x approaching to 0, sorry, this will not be x, this will be t, where sine 2t upon a t square plus 4t is equal to dash. Now as soon as you put 0, everybody check here. If you put t is equal to 0, what will you get? You will get sine 0 upon 0 plus 0, which is 0 by 0 format. Whenever you get 0 by 0 format, we try to eliminate this intermediate form. Now, first, how can we eliminate this form? So, we know the formula that if we have sine 2t and I divide it by 2t, this will become 1 when the limit is, no space to write the limit, wait. When the limit is t approaching to 0, then if I do sine 2t upon 2t, my answer will be 1. I know that. So what am I doing here? I take my function limit t approaching 0, sine 2t upon a t square plus 4t. So I want sine 2t upon 2t. So what I will do? In the numerator and the denominator, I divide 2t. So now I get limit t tends to 0, sine 2t upon 2t into limit t tends to 0, 2t upon a t square plus 4t, right? Let's simplify this. This function becomes equal to 1. I told you, if it is sine x upon x, where x is approaching to 0, it will be 1. So this becomes 1. Now, multiplied by what happens here? So let's see what will happen if we divide a t square plus 4t by 2t. So our answer will be limit t tends to 0. So this will be 1 upon 2 a t square divided by 2t is 4t plus 4t divided by 2t is 2, right? Now you put t is equal to 0. So you get what? You get 1 into 1 upon 0 plus 2. So this is 1 into 1 by 2. So answer is 1 by 2. So your answer will be 1 by 2. So like this, we removed 0 by 0 format. There are different methods of removing 0 by 0 format. So first method we have learnt is we basically convert it into the known properties that we have. So one property that we know is sine 2t divided by 2t is 0. So we used that property to eliminate 0 by 0 format. Clear? Okay. Yeah. Next, limit x tends to 0, x upon 9 minus x minus 3. Now this is again 0 by 0 format. Now, second method for removing 0 by 0 format. You can simplify your function and see whether 0 by 0 format is getting reduced. So how can I simplify this? Whenever I see root in the denominator, I use the format a minus b into a plus b. So what we can do here is x, first I am not writing limit, I am just simplifying this first, okay. 9 minus x minus 3 multiplied by root over 9 minus x plus 3. Similarly multiplied by root over 9 minus x plus 3. Let's see what will happen. So we get x into root over 9 minus x plus 3 upon, when we multiply this, what do we get? A minus b into a plus b, a square minus b square. So 3 square is 9. So 9 minus 9, 0, right? Yeah, here it will be 3x because x will be multiplied to both root and 3, right? Now, what is left? We have x common, root over 9 minus x plus 3 divided by minus x, right? Yeah. Now, x cancelled, we get minus of root over 9 minus x minus 3. Why? Because minus sign will be multiplied to both the terms. Now, we put here limit x tends to 0. So, basically, we put x is equal to 0. So, what do we get? We get root over 9 minus 0 minus 3. So negative of root over 9 minus 3. That is root over 9 is minus 3. So minus 3 is minus 6. So what is your answer? Minus 6. Okay. So here we used rationalization. Rationalization as our basically method to eliminate 0 by 0 format. So first we learned how to use the known formula. Second, rationalization. Okay. Next, another method or another type of question that you can get. Suppose they have given our function is 3x plus 2 for x less than minus 2 and this for x greater than equal to minus 2. Then the left hand limit and right hand limit are respectively dash. How do you find out left hand and right hand limit? Note down carefully. Left hand limit is basically limit x tends to 2 negative minus 2 negative because approaching it from the left hand side of fx. This is equal to limit h tends to 0. Now what is h? H is a value which is very small. It's like almost 0. Okay. A limit h tends to 0 f of minus 2 negative. That means for less than minus 2 whatever is your function. So now let's put the value. Left hand limit will be, so basically the correct method to write this is f of minus 2 minus h. Why? Because if you want to make your variable, your input less than minus 2, then you have to subtract something. We are subtracting here h because we are assuming h to be a very negligible small value, but it is a value. It's not 0, it's almost 0, like that. So this is the formula. Now just put x is equal to this. So what do you get? You get limit h tends to 0. In this function we put 3 minus 2 minus h plus 2. So it will be limit h tends to 0. Open the brackets, 3 2s are 6 and minus 3h plus 2 minus 6 plus 2 minus 4. So you have limit h tends to 0 minus 4 minus 3h. Now you put h is equal to 0. What do you get? You get minus 4 as the answer. Right? You get minus 4 as the answer because when h is 0 then this value becomes 0. So minus 4 is the answer. Okay. And should we cross check? 3 minus 2 plus, yeah, correct. So we get minus 4. Now we need to find the right hand limit. Let's find out the right hand limit. Now I will use a little shortcut here because I have already explained you, right? So limit h tends to 0, it will be f of minus 2 plus h. Minus 2 plus h function. So minus 2 plus h function will be what? This function, because it is greater than minus 2. So we will put minus 2 plus h whole square. Minus 3 into minus 2 plus h minus 1. Expand it. So it is minus 2 square is 4, h square is h square and minus 2 into 2 minus 4h. Then 3 2s are 6 and minus 3h and minus 1 where limit is h tends to 0. So this is limit h tends to 0. We have 4 plus 6, 10 minus 1, 9. So 9 plus h square minus 7h. Now you put h is equal to 0. So you have 9 plus 0 minus 0. So answer is 9. So your right hand limit is 9 and your left hand limit is minus 4. So this should be your answer. Minus 4 and 9. So now you understood how you have to find out the left hand limit and the right hand limit. Okay, let's move on. Next, third method to find out limit of a function where you have 0 by 0 format. So the third method is, if you don't know the formula, there is no formula for polynomial function. Second, You cannot rationalize it. Third, basically what we can do here is we can find f dash of x. We use L'Hospital's rule that limit x tends to minus 3 of fx upon gx is equal to limit x tends to minus 3 of f dash x upon g dash x. So what do? If this is fx, you find out limit x tends to minus 3 f dash x upon g dash x. This will remove the 0 by 0 intermediate form. So what is f dash of x? Limit x tends to minus 3 f dash. If you differentiate this, what do you get? You get 2x plus 16. Denominator 2 2s are 4x plus 7. Now you put x is equal to minus 3. So you get 2 into minus 3 plus 16 upon 4 into minus 3 plus 7. So 3 2s are 6. 16 minus 6 is 10. 4 3s are 12. 12 minus 7 is 5. But since here minus 12, so it is minus 5. 5 2s are 10. So answer is minus 2 and we had space. So the answer is basically 10 upon minus 5 is minus 2. Simple. So whenever it is 0 by 0 format, what you can do is you can find f dash of x, g dash of x, and then put whatever limit value, whatever x value is given. Clear to all of you? Okay. Let me check my camera. It's fine or not. Okay. Next question. Limit t tends to 0. This. Another method. Fourth method. Since you don't know the formula of this, you cannot rationalize it. You don't need to differentiate it. So you just need to simplify it. So what happens is sometime if you put t is equal to 0 here, you will get 0 by 0 format. But if you open the bracket, things may change. Let's have a look. So this becomes limit t tends to 0. We get 2t into t, 2t square minus 3t minus 2 2s are 4t and plus 6 whole by t minus 3t and 3 2s are 6 upon t. Now this is also denominator t, this is also denominator t. So t can be taken out common. Now if I open the bracket here, what will happen? If I open the bracket, this will become minus 3t minus 6, right? Now you simplify. Plus 6 minus 6 cancel. Limit t tends to 0. 2t square minus 10t divided by t. Now you just divided by t. You get limit t tends to 0. 2t minus 10. Now you check, is it 0 by 0 format? No, we removed 0 by 0 format just by simplifying. Just by opening the bracket, 0 by 0 format is removed. Now you simply put t is equal to 0. So 2 into 0 minus 10 is minus 10. This is your answer. So this is the fourth method to remove 0 by 0 intermediate form. Clear to everybody? And it is not just 0 by 0 form, infinity by infinity, 1 by infinity, infinity to the power 0, infinity 0 to the power infinity. Any of this form can be removed by simplification, factorization, rationalization, or using the identities or L'Hospital's rule. Okay. Next question. If your function is this for x less than minus 3 and greater than minus 3, then what is the limit of the function for x tending to minus 3 plus? What is the meaning of this? They are asking the right hand limit only. They are not asking left hand limit. They are just asking what is the value of right hand limit. How do we find out right hand limit? So, right hand limit is equal to limit h tends to 0 f of minus 3 plus h. Now put in the value. For greater than minus 3, what is your function? Minus 3 plus h. So in place of x, we are writing minus 3 plus h. In place of cos x, we will write what? Cos pi by 3 into minus 3 plus h. So this will become minus 3 plus h into cos 3 cancel, minus pi plus pi by 3 h, right? Now there are two trigonometric formulas used here. What are they? Formula number 1. If I take out negative sign as common, so basically cos of minus theta is cos theta. So here if I take out minus sign as common, minus 3 plus h, now cos, this can be written as pi minus pi by 3h. Okay, because cos of minus theta is cos theta. So if I take out negative sign common, it will be pi minus pi by 3h and it will be same. Second formula we use here is cos pi minus theta is minus cos theta. So here we will get minus 3 plus h into cos of pi minus theta is minus pi by 3h. Now we put limit h tends to 0. So now we put h is equal to 0. So we get minus 3 plus 0 into minus of cos 0 degree. So this is minus 3 into, what is cos 0 degree? 1. So minus 3 into minus 1, 3. So this is your answer. Understood? So two formulas used here. Cos of minus theta is cos theta. Cos minus pi minus theta is minus cos theta. So therefore, from here to here, we have to use two formulas for trigonometry. Okay. Next, this by this is equal to dash. Now just by looking at the function, I know I don't know any identity. There is no bracket to be opened. There is no rationalization possible. So I will use L'Hospital rules. I will find f dash of x, g dash of x. So just find differentiation of both the functions. So limit x tends to 0. Differentiate this. Differentiation of log x is 1 upon x plus differentiation of 1 is 0. So 0 minus differentiation of e to the power x is e to the power x. So e to the power x. Denominator. 4x square differentiation is 4 to the 8x. 9x differentiation is 9. Now you put x is equal to 0. So we have 1 upon 1 plus 0 minus e to the power 0 upon 0 minus 9. So this is equal to 1 minus e to the power 0 is what? E to the power 0 is 1. So 1 minus 1 upon minus 9. So 1 minus 1 is 0. 0 upon minus 9 is 0. So your answer is 0. Understood? Just differentiate, put x is equal to 0, get your answer. L'Hospital's rule. Next, as soon as I see sine function, what is the formula? Formula is sin x upon x is equal to 0. So if my function is limit t tends to 0, sin t square upon t sin 5t. So what I want to do is, I need to convert it into the form of sin t square by t square. Then only it can be 1. So what I will do, I will try to convert it into that format. So let me divide it by t square and let me also divide this by t square. Let's see what happens. So it becomes limit t tends to 0. So this is sin t square by t square into limit t tends to 0, 1 upon t into sin 5t upon t square. So t cancel. Now this, what is the value of this? Directly sin x upon x is 1. So this becomes 1. Now limit. Here t cancel. T tends to 0. I have 1 upon sin 5t upon t. Now again, sin x upon x is what? 1. So I want x and x to be same. So what I will do? I will multiply this by 5. I will multiply this by 5. So now it becomes 5t upon 5t. So 5t upon 5t is 1. So again I have 1 into 1 upon 1 into 5. So my answer is 1 by 5. Option number D is your right answer. Alright. Next question. If limit x tends to -2 is a finite number, then the value of a is equal to dash. Interesting question. Very, very unique question. See, every question I have shown you today is unique and you are learning something new from it. From this question, what are we learning? They have not told what is the limit and they are asking the value of a. How we will find out a if we don't know what is limit? Like, if there is no equal to sign, there is no value given. They are just saying it is a finite number. Then what can we do? Then we have to apply a trick. So the trick here is, bachcho, please listen carefully. Now, in the denominator, when I put -2, what am I getting? Let's check. So when I put the values here, I get 3 into -2 whole square plus a into -2 upon -2 whole square -2 -6. So I get 2 2s are 4, 4 3s are 12 -2 -2a upon I get 4 -2. No, minus of -2 will be +2. 4 plus 2 -6. So I get here 10 minus 2a upon 6 minus 6. So 10 minus 2a upon 0. Now what do we understand here? If the denominator is 0, then it will be infinite. It will be undefined. But in the question they are saying it is finite. How is that possible? It is only possible when your limit is 0 by 0 format. If your denominator is 0, your numerator should be 0. So this implies that 10 minus 2a should be 0. So 2a will be 10. So a will be 5. This should be your answer. And option D is your right answer. Understood? It was tricky question, twisted question. Denominator is coming 0, but limit is finite. How is that possible? It is only possible if it is 0 by 0 format. Then only the limit will be finite. So that's how we got A as 5. Clear to everybody? Okay, so limits chapter is over now. I have told you guys different unique type of problems which will help you basically solve any question of limit. So try rationalizing it, factorize the denominator, simplify the brackets, apply L'Hospital's rule, f dash x upon g dash x. Any other method? No. So 4 methods basically to find out limits. Fifth method, apply the properties that we know: sine, cos, tan, log, e, a. Just use these formulas to simplify. So these are the 5 methods using which you can basically simplify the function and find out the limit. Okay, so mostly they will give you 0 by 0 format only, mostly, or they will ask you left hand limit or right hand limit. This is what they do every year. So now are you guys confident enough? You can do this chapter? Alright, now let's learn about application of derivatives. Okay, so in application of derivatives, basically we are going to learn about rate of measure, maxima, minima and increasing, decreasing functions. First is rate of change of any body. Now basically, suppose we say that there is a pipe, that pipe is filling water. Okay, so in a tank. Now in the tank, the volume of water will keep on increasing if it is filling it. So at any particular instant we can calculate rate of change of volume of that tank, right? Now how do we calculate rate of any measure? So basically rate is the small deviation in volume with respect to time. So similarly, if we have a independent variable depending upon an independent variable, then rate of change is basically first order derivative of that function. So suppose I want to find out rate of change of area of circle with respect to radius. So it will be what? dA by dr, because the area is changing with respect to radius, or the volume is changing with respect to time. So like this, the rate of change can be calculated by differentiating it with respect to the independent variable. Okay. Next, very important concept of this chapter is tangent and normals. So for any curve we can find out tangent if it is a continuous and differentiable curve. And why we say that it should be differentiable? Because slope of tangent can be found out only by differentiating the function and getting the dy by dx value. Okay, so it's not just dy by dx, it is just like dependent variable with respect to independent variable. So slope of tangent for a curve y is equal to fx is dy by dx at the given particular point. So at this point tangent, or at this point the tangent, or at this point tangent. So at any point you can calculate slope of the tangent and it will be dy by dx at that particular point, also written as tan theta. So theta is the angle made with the x-axis, right? Now what will be slope of normal? Normal is basically perpendicular to tangent. So slope of normal will be minus of 1 upon tan theta. Minus of 1 upon tan theta is minus of cot theta. So it is basically negative of slope, reciprocal of slope of tangent. So if slope of tangent is dy by dx, this will become dx by dy with minus sign at x1, y1. So this is slope of normal. Now equation of tangent, equation of normal is same as equation of straight line. You know the slope, you know x1, y1, you can find out the equation. Okay. So suppose you have point x1, y1 and you have the curve y is equal to fx. So equation of tangent will be same as a straight line. Y minus y1 is equal to m into x minus x1. And what is the slope here? Dy by dx. Similarly for normal, y minus y1 into m into x minus x1. And what is the slope here? Minus dx upon dy at x1, y1 point. Alright, so this is the equation of tangent and normal. Every year they ask a question from tangent and normal. Okay. Now, next is, suppose you have two straight lines, how will you find the angle between them? So, this is related to straight lines but also used in tangent and normal. Now if the two lines are basically intersecting, the angle between them tan theta will be slope. So m1 minus m2, slope of the two lines upon 1 plus m1 m2 mod value. Okay. Next, increasing and decreasing function. So using differentiability concept, using derivatives concept, we can check whether the function is increasing or decreasing. How will it increase? Very simple. For any a less than b, if f of a is less than f of b, then it is an increasing function, because if the input increases, output increases. So obviously it's an increasing function. Similarly, for a less than b, if fa is greater than fb, means when the input is decreasing, output is increasing. So this is a decreasing function. And the example of decreasing function is log functions. Understood? Now how do we check it is increasing or decreasing function? So first we find out f dash of the function of the curve. If f dash of x is greater than 0, it is increasing function in the interval a to b, where x belongs to a to b. And if f dash x is less than 0, it is decreasing on the interval a to b, right? Next, similarly, we have the concept of maxima and minima. Why? Because every curve is like increasing, decreasing, increasing, decreasing. Some curves are like that. Suppose sine graph is like this. Cos graph is like this. So sometimes they are increasing, sometimes they are decreasing. So every graph sometimes has a maxima point and a minima point. That is the peak and the valley point, right? Now this peak and valley points are called maxima and minima. Now suppose I have a curve where there are lot of maximum points. Here also it is peak, here also peak, here also peak. But if you observe all of them, which is the maximum value, this is the maximum value curve is attaining. So all these max values are called local maxima. And out of local maxima, whichever is the greatest is called global maxima. So this is like class topper and this is like state topper. So now you understood what is local maxima and global maxima? Now, how do we determine at which point we get maxima and minima, increasing and decreasing? For that we need critical points. Now, what are critical points? Critical points are the points for which f dash c is equal to 0 or for which f dash of x changes sign from positive to negative. Basically, any point where the function is reaching peak value or minimum value, it is called as critical point. And how can you find out critical point? Simply just find out f dash of x, put this equal to 0 and get x1, x2, x3 for which f dash of x is 0. So you get the critical point. After that, how do you determine it is a local maxima or a local minima? So first, if it is local, where is my pen gone? Yeah, if it is a local maxima, then f dash of x will go from positive to negative. Okay, it is a increasing and then decreasing function. Then only maximum will be reached. Now, to find out local minima, simply if it is decreasing and then increasing, then you will get a minimum point. So, find f dash of c equals to 0 and check f dash of x is changing sign from negative to positive, then it is a local minima. Now, is there any simpler method to do this? Yes, there is a better method for this. And the better method is, you find f dash of x, you find x naught for which f dash is 0. Then, for this point, you check if f double dash of x, that is second order derivative, is less than 0, then it is local maxima. Greater than 0, then it is local minima. If it is equal to 0, it is saddle point, also known as inflection point. In the exam, they can ask you, what is the saddle point? What is inflection point? So, f dash x should be 0 and f double dash x should be 0. Then you can call it as inflection point. Clear? Now, here remember, less than 0, maxima. It is opposite. Like, we think that if it is less, then it should be minimum, but it is not like that. It is less than 0, but maxima is defined. Greater than 0, minima is defined. Okay, so this is maxima minima test. Last two topics of this chapter are Rolle's theorem and Lagrange's theorem. So basically, mean value theorem says that if a function fx is continuous in the closed interval ab, differentiable in the open interval ab, and f of a is equal to f of b, then there is a point c in the interval ab such that f dash c is equal to 0. Similarly, Lagrange's mean value theorem says that, let me move to this side. It says that if a function fx is continuous in the closed interval ab, differentiable in the open interval ab, then there is a point c in the open interval ab such that f dash of c will be fb minus fa upon b minus a. Remember this, it is sometimes used in solving some questions. Okay, so f dash of c is fb minus fa upon b minus a for a point c in the interval AB. Okay. Next. Now let's solve some question and let's see what type of questions are going to come in your exam. Number 1. If the tangent line to the graph of the function at the point x is equal to 3 has x-intercept 5 by 3 and y-intercept minus 10, then f dash 3 is equal to dash. Wow, very interesting and unique question. Let's see what we have to do here. First of all, equation of a tangent line will be y is equal to mx plus c. Now what is c? C is the y-intercept. We all know that. So, at this point they are saying y is slope into x and y-intercept is given minus 10. So, y is mx minus 10. Now, this tangent line at x is equal to 3 has x-intercept 5 by 3. Now, what is x-intercept? X-intercept is basically when y is 0, x is 5 by 3. Let's put it over here. What do we get? 0 is m into 5 by 3 minus 10. So, we get 5m by 3 is 10. Yeah. M is 3 into 10 upon 5. 5 2s are 10. So, 6. So, the slope of the tangent is 6. But is that your answer? No. They are asking what is f dash of 3. So, first we need to find what is fx. What is my curve? So, my curve is y is equal to mx plus c. Y is equal to 6x minus 10 because c is minus 10, m is 6. We have just now found out the value. Now you differentiate it. So, f dash of x. What is y? Y is fx. So, f dash of x is you differentiate this. 6 differentiation is 6 minus 10 becomes 0. So, your answer is coming. F dash of x is 6. So, f dash of 3 will be 6. F dash of 3 will be 6. Clear to all of you? Okay, moving on. Slope of the tangent line to this curve at point 1, 2. Easy? Not easy? Well, it is easy. What is slope of tangent? Slope of tangent is dy by dx. That means I have to differentiate this. Let's differentiate the function. So, 4x square 2xy y square is equal to 12. I am differentiating it with dy by dx with respect to x. So, I get basically I am just differentiating it with respect to x. So, I get 4 2s are 8x. Then 2xy will be like product rule will be applied. So, it will be 2y plus 2x into dy by dx plus 2y dy by dx is equal to 0. So, it is 2x plus 2y common dy by dx is equal to minus 8x minus 2y. Now, sending it to the denominator, 2x plus 2y will come here and this we will remove. So, dy by dx is this. Now, they are asking what is the slope of tangent at x is equal to 1, y is equal to 2. Put the values. So, dy by dx will be minus 8 into 1 minus 2 into 2, 2 into 1 plus 2 into 2. So, this is minus 8, 2 2s are 4 and 2 plus 4. So, we have minus 12 upon 6. So, 6 2s are 12. Minus 2 is your answer. Understood? Simple. Whenever they ask slope of tangent, what will you do? You will find out dy by dx only. How to find out dy by dx? Differentiate the function, get dy by dx, put 1 and 2 and get the slope because x and y value is given in the question. Okay. Next. Let f of x is root over x plus 5 for x between 1 to 9, then the value of c whose existence is guaranteed by the mean value theorem is dash. What is the formula? The formula is f dash of c is fb minus fa upon b minus a. So, here a is 1, b is 9, put everything in the formula. What do you get? So, first let's find out f dash of c. So, here what is f dash of x? Like how, like when you differentiate it, what do you get? Root over x differentiation is 1 upon 2 root x, right? 5 differentiation is 0 is equal to, now we have to put c in place of x. So, it will not be x, we will write it as c. Now, what is fb? So, fb is basically root over 9 plus 5 minus root over 9, root over 1 plus 5 upon 9 minus 1. So it is 3 plus 5, 8. 1 plus 5, 6 upon 9 minus 1, 8. So this is 2 by 8. 2 by 8 is 1 by 2 root c is 2 by 8. 2 4s are 8. So we have here 2 root c is 4. So root c is 4 by 2 and c will be 2 square. So c is 4. So my answer is C is coming out to be 4. So we use mean value theorem, putting here all the values and just put everything in the formula. Get your answer. Simple. Nothing else. Like it is direct formula based question. Okay. Next, the derivative of the function is given by f dash of x is x minus 5 upon root over x square plus 5. Then the interval in which f is increasing. How to find out increasing, decreasing function? Put f dash of x equals to 0. So x minus 5 upon root over x square plus 4 is 0. So denominator goes to right hand side, becomes 0. So x minus 5 is 0. So x is 5. This is my critical point. This is my critical point. Now at this point I have to determine it is increasing or decreasing function. So how you do that? Well, to do that you have to find out. Basically we will draw our number line. So from minus infinity to 5 and to infinity. Now you have your critical point, you have your function, check. So when you check for value less than 5, what do you get? So if x is less than 5, suppose it is 4. So what do you get? You get 4 minus 5 upon root over 4 square plus 4. Now this is minus 1 upon let's say 16 plus 4 root over 20. So this is a negative value. It is a negative value less than 0. So it is coming negative. Now put value greater than 5. Put any value. Take any example greater than 5. What do you get? You get, suppose I take 6. So 6 minus 5 upon root over 6 square plus 4. This is 1 upon root over 36 plus 4 is 40. Now this is a positive value. So I am getting a positive value. So my function is basically from minus infinity to 5 is coming negative. From 5 to infinity it is coming positive. So I will say that from 5 to infinity it is an increasing function because the answer is coming positive. F dash of x is greater than 0 for values greater than 5. Okay, f dash of x is greater than 0 for values greater than 5. It is less than 0 for value less than 5. So increasing, decreasing we have learned. If f dash x is greater than 0, it is increasing function. If f dash x is less than 0, it is decreasing function. Okay, simple. Next, this is rate of change question. Whenever you see a word problem, it is that only. A cube is expanding in such a way that its edge is increasing at the rate of 2 inches per second. So, it is given basically dE by dt. Rate of change of edge with respect to time is 2 inches per second. If its edge is 5 inches, so edge value is given 5. Rate of change of volume will be dash. So first, what is the formula of volume? Volume of a cube is edge whole cube, right? So dV by dt will be dE by dt. We are differentiating it with respect to time. So dV by dt is 3e square into dE by dt. Differentiating the edge with respect to time. So this is equal to 3 into e square into, what is dE by dt? 2. So this is 3 into, what is the edge value? 5. So 3 into 5 square into 2. So it is 3 2s 6, 5 5s 25, 25 into 6 is 150. This should be your answer. 150 inches cube per second because we are finding out volume rate of change. So 150 inch cube per second is the rate of change. Understood what you have to do? First you have to write volume formula and then differentiate both sides with respect to time. Why? Because per second is given. So per time we are differentiating it. Understood? Okay. Next question. Let fx is x square log x. Then the minimum value of f is dash. How to find out local minima? Local minima is first f dash of x should be equal to 0. Second, f double dash of x should be greater than 0. Then you find out f of x. So step number 1. What is f dash of x? F dash of x is differentiate x square into log x. So 2x into log x plus x square into log x differentiation is 1 by x. So this is x into 2 log x plus x cancel x. So x taken out common, 2 log x plus 1. This is f dash of x. Now step number 1 is f dash of x is equal to 0. So if this is equal to 0, in the question they have written x is greater than 0. That means x is not 0. So if x is not 0, this is 0. Now here we say that first thing, can I write 2 log x? 2 log x plus 1 is 0. 2 log x can be written as log x square plus 1 to be 0. So we say that log x square is minus 1. Now we take base e on both the sides. So base e, we get x square is e to the power minus 1. So this is the value of x. So we get x is basically 1 upon root over e. So we have x. Now we need to find out f double dash of x is greater than 0 or less than 0. So let's check. What is f double dash of x? Oh. So we will differentiate this x into 2 log x plus 1. Let's differentiate that. What do we get? X into 2 log x. X into 2 log x plus x. Double differentiation. So f dash of this is what? So when I differentiate this, x differentiation is x. So it will be 2 log x plus x into 2 into 1 by x plus 1. X cancel. So we have 2 under 2 plus 1, 3. 2 log x plus 3. Now you have to check it is greater than 0 or less than 0 at x is equal to 1 upon root e. Put the value here. So you have log x square plus 3. What is log x square? Log 1 by root e. 1 by root e whole square plus 3. So this is log 1 by e plus 3. Log 1 by e is basically log base e to the power minus 1. So this is minus 1 plus 3. Minus 1 plus 3 is 2. What is 2? 2 is greater than 0. So my function is coming greater than 0. That means this x value is correct. So till now we are just determining whether x value is correct or not. So x value is correct because f double dash x coming greater than 0. So now at the end I will find out f of x when x is 1 upon root e. So put here 1 upon root e. What do you get? So you get 1 upon root e whole square into log 1 upon root e. So this is basically 1 by e log base e to the power minus 1 by 2. So minus 1 by 2 come friends. So it becomes minus 1 by 2e. Okay. So basically in your KEAM exam, you don't get so much time to check f dash x, f double dash of x and then you find fx. So what you can do is, if you are getting only one x value, okay, I'm telling you a trick. If you are getting only one x, there is no other x, you are getting only one value, and there is no option which is saying undefined, then no need to find out f double dash x, you directly find out fx. Because if there is no option saying undefined, then no need to check it is minima or maxima. If there is an option saying that no minima point, then only you have to check f double dash x, right? So you can avoid f double dash x if there is no option saying undefined or no minima value, okay? So yeah guys, that's all about limits and application of derivatives. These two chapters are important. Lots of questions are asked from them. So hope you prepare well. That's all for today. Thank you for watching the lecture. Keep subscribing to the channel and joining every day for the marathon Minnal KEAM series going on for you, where we are doing maths, physics and chemistry revision and PYQs and formula cheat sheets and so many things coming up planned for you. So do subscribe and hit the like button if you enjoyed. Thank you for watching the video. Bye-bye.